Many of you know Greg. He's a conservation ecologist and a land use planning consultant with over 40 years of experience in a wide range of activities related to forest management and biodiversity. And he's currently focused a lot on adapting biodiversity conservation measures to the realities of rapid climate change. And he's worked with a variety of climate clients, including government, non-government, First Nations, forest industry, in both in BC and Southern Africa. And he has been developing these south to north conservation corridors as part of Kutenai Connect. So he'll be talking about that. Welcome.
So thanks very much for this opportunity to say a few words about some work that I've been doing over the past few years. I'm going to talk about, as Juliette said, conservation disruption and conservation corridors. And just to sort of start off, I'm just going to show a few background slides to say, why is this an issue? Basically, over the past 800,000 years, we haven't had more than 300 parts per million of CO2, and now we're up to 416. And in the 10 years I've been doing these presentations, it's gone from 390 something to 416, and it's continuing on because we're not doing anything about it. What this says for the Columbia Basin, various models show that we're looking at, by the 2050s, it's only 3 decades from now, we're looking at an increase in temperature by 2 to 3 degrees, and particularly larger increases in the summer. And when we look at the projected changes in precipitation, precipitation actually increases slightly in the range of 10% for 3 seasons, but in the summer, it actually goes down. So we're looking at basically warmer, drier growing seasons, which obviously is going to have a significant impact. We're talking about corridors, and partly that is because what we're looking at is that species are going to have to shift their ranges with those changes in temperature and precipitation. This is some work that was done by Laura Gray some years ago, looking at habitat projections for ponderosa pine, and this is an average of 18 different scenarios. And it's using the bioclimate, in other words, the climate that ponderosa pine exists in. And this is where it exists today. This is where it's projected, well, I should say where it was a couple decades ago. This is where it's actually projected to be in the next decade. And if you look at the 18 models, and this one here, what it's saying is whether the models agree or the scenarios agree or disagree. If it's red, all the scenarios said no ponderosa pine. If it's dark blue, all of them said yes, ponderosa pine, and the variations in between indicate that there's some variation. This is what's projected for the 2050s. You can see ponderosa pine is moving north, and secondly, it's moving up in elevation. And of course, as you go to the greens and blues, it's a higher density, and the yellows, it's a less density, less dense. And if we go to the 2080s, you can see that it's pretty well taken over all of the Columbia Basin and expanded its range dramatically. Now, this work that was done by Gray also looked at a bunch of other species for Western North America. And you can see on the upper right there, I've listed the species that were involved, a lot of species that do exist here in the Kootenays. And they looked at the range of those species and divided them into sub-regional populations, and then projected where those are going to go in the coming decades. And if you look at, there's basically a northward shift over the decades, as well as if it doesn't move north, it moves up in elevation for almost all of these species. And this is kind of an average of all the species. And this is from where they were in the 1970s. And already at that time, the average bioclimate envelope for that particular species or that particular regional population of a species had moved up 70 meters and 160 kilometers to the north. And in the next decade, we're doubling that essentially. And then by the 2050s, it continues to increase. So some of these species are going to have to move significantly upslope, 250 meters, or north by somewhere between 500 and 600 kilometers. So we're talking about tremendous shifts in ranges. But it's not quite that simple. That's easy. We're looking at single species. But if we think about the ecosystems in the Columbia Basin, right now, this is the biogeoclimatic mapping. You can see in the West Kootenays, we're dominated by interior cedar hemlock at the lower elevations, Engelmann spruce subalpine fir in the upper. And the East Kootenays, we've got a bit of a ponderosa pine, which has been remapped as a really dry Douglas fir, and then moving into montane spruce and then Engelmann spruce, but a much drier Engelmann spruce in the East Kootenays. Now, if you look at the scenarios moving forward, this is some work we did a few years ago, which looked at 3 different scenarios for the Kootenays or for the Columbia Basin. And you can see that all of them are showing tremendous expansion of grassland and steppe habitats at the lower elevations. And the other thing you'll notice that in virtually all the cases, the area of Engelmann spruce subalpine fir, be it dry or wet, is either severely reduced or has completely disappeared. And you'll notice that in the upper elevations, there's quite a bit of variation between the 3 scenarios, which leads quite nicely in the focus of this workshop is uncertainty. We're very uncertain about what's going to happen in the upper elevations. But I think relevant to the discussion right now is where do those ecosystems exist today? The model that made these projections had looked over Western North America to find similar climates to what are projected for the Kootenays in the future and said, where do those climates exist today? And this map here shows where the model had to go to find those. So this relates back to that fact that things may be moving 500 or 600 kilometers. Now, if you think about it, it's nice to talk about it in terms of Beck units. You can think, well, they're just going to shift from one place to another, but that's not really what's going to happen. Because every species that exists in an ecosystem has slightly different tolerances and different demands, they're likely to look at fairly severe ecosystem reorganization. And there's going to be a lot of new species coming in. We're going to get completely different ecosystems than we had before, although they may have some traits, similar traits to the ones we have today. But as these things begin to shift, when you think about the Columbia Basin here in the Kootenays, there are certain barriers to range shifts. One are the natural barriers, such as mountainous topography on the map on the right. The browns and yellows indicate parkland and alpine areas, or significant mountain ranges that are going to make it so that lower elevation species aren't going to be able to move in those directions. And then we've got ice, bare rock, lakes, waterfalls, things like that that create discontinuities in habitat. And then we've got what we've overlaid on this, and in the map on the right, the pinks and the reds indicate existing roads. The darker the color, the higher density of use. We've also got urban and rural developments, agriculture, and reservoirs, which inhibit movement. There has been a lot of work done looking at connectivity and the possibility for range shifts and species movement. Some of it is looked in general. And of course, here in the basin, Michael Proctor has done a fair bit of work looking at connectivity for grizzly bear movements. There's also, over the last 10 years, a fair bit of work has been done looking at broad scale regional connectivity or even continental connectivity. Some of it very detailed, like the lower left by Nunez, where they're looking at trying to trace where a climate moves across the landscape. The one on the right is looking at potential areas where shifts may occur in the Rocky Mountains. The other thing to do is looking at some of the kind of things that Casey talked about on a micro scale to looking at those on a macro scale is where here in the Columbia Basin are going to retain cool, wet environments similar to what we have today. There's some work I did with Y2Y looking at potential wet, cool refugia on a regional basis using those three scenarios that I mentioned earlier. And the other possibility is to try and map these linkage zones that may provide corridors for range shifts to occur. And I'll just talk a little bit about, this was the mapping that we've done previously looking at potential corridors through the Kootenays. How did we find the corridors? Well, we look for north-south orientation and topographic diversity because species may be moving upslope as well as moving north-south. We also emphasize low elevation passes where species can move between major valley systems, looked at areas that are intact and lack of human-made barriers and existing conservation areas which may have a higher level of management, which is a higher likelihood of species being able to survive. and looked at using riparian corridors and wetlands. So these large corridors that are mapped in the orange tried to make use of existing protected areas, but as you all know, most of the protected areas in our area are at high elevation. There's very few at low elevation. We also looked at existing conservation areas, some of the ones that KSAP has acquired, also other ones that are set aside by the government, and other types of management such as caribou habitat. What kind of management strategies would we be suggesting for these? Well, an emphasis on ecosystem resilience for the future projected climates. We used to talk about the range of natural variability. Now we need to begin to talk about the future ranges of variability. We're talking about maintaining and restoring stand level habitats, old growth patches, deciduous, maintaining appropriate cereal distributions, minimizing access, assessing and managing in a landscape context. And I just might mention these 4 areas that Kutenai Connect is looking at do fall within these corridors. So they obviously would be contributing to this kind of strategy.